Okay, so we're going to come to a topic now which is most likely going to be new to most students, and it is modulus and modulus functions. So let's do a quick intro. There are three parts to this lesson. We're going to look at what is the modulus function. We're going to look at modular equations and solving them, and then modular inequalities. So you can see we're going back to some old ideas as well with equations and inequalities, but we're going to be applying it in this new scenario. So what is the modulus function? So the modulus of A, written as those vertical bars, we often say mod A, is its non-negative numerical value. So basically, modulus of 4 is 4, but the modulus of minus 3.2 is 3.2. It basically means drop off the minus, ignore the minus. The modulus of a value gives its magnitude or its size. Now, if you think about a number line, okay, and if you think about where 0 is on the number line, so if we put a 3 here and let's say a minus 4 there, the position of this 3 is at 3 on the number line, but its distance from 0 is 3 units. Now the 4 has a position of minus 4, but what is its distance from 0? Its distance is actually 4 units, even though it's in the position of minus 4. If you think about length or distance or magnitude or size, it's actually 4 units from 0. So we often call this absolute value or magnitude. So if mod x is equal to 5, then x might have been 5, or it actually might have been negative 5. And then when the modulus was put around it, we're saying then its absolute value or its modulus is 5. But before it got modulused, that's not a real word, it could have been 5 or minus 5. But we definitely know that mod x squared is equal to 25 because mod x is positive 5. So positive 5 squared is 25. Let's have a look at the graph then of the modulus function. So you're going to get some graphs now in this section that are unusual to you. They're going to be very pointy. Usually our graphs are freehand, curved, and nice smooth graphs, but we're going to be looking at some pointy graphs here. So let's look at our basic. This would be what we would consider our parent graph. This is your basic, most straightforward modulus graph. So the parent graph, y equals mod x. So let's see. If x is minus 2, we said if x is minus 2, the modulus of minus 2 is 2. So y is 2. Likewise, the modulus of minus 1 is 1, modulus of 0 is 0. The modulus of 1 is still 1. So if it was positive before, that's fine, it stays positive. Now, if we plot all of these points, minus 2, 2, minus 1, 1, 0, 0, 1, 1, and 2, 2, you'll see you get this V shape. Now, if you think about the graph of y is equal to x, which is related to this modulus graph, except, the only difference is the modulus bars, the graph of y is equal to x would have actually continued down like this. You would have had minus 1, and minus 2, minus 2. So all that's happened is this section of the graph here has just been reflected up to the top. It's been reflected through the x-axis, kind of bounced up. So there are no negative y parts allowed here. It's just been all popped up into the positive y section. So if we want to sketch y is equal to ax plus b, we sketch y equals ax plus b without the magnitude. And hopefully you've got those graphing skills. You'll be able to do that from before. We haven't covered it yet in this course. We will touch on it, but it is kind of assumed knowledge. Then you draw the graph y is equal to ax plus b and you reflect up. Anything that's below the x-axis, you just bounce it up there, reflect it up. So this here with the dashed line is the graph of y is equal to 2x minus 3. All of that. But this V shape is the graph of y is equal to mod 2x minus 3. So the section that was below the line has been reflected up. Let's have a go at sketching some of those here ourselves. So I will give you a quick whistle-stop tour of sketching graphs, but really you probably need to go back to your previous textbooks if you need a bit more on this. So let's sketch y equals 2x minus 5. It's a linear graph, y equals mx plus c. C is the y-intercept, is minus 5. So at 0, minus 5. So I'll mark that. There's the y-intercept. M then is the gradient or the slope. So the slope M is equal to 2. So what we've got now is we've got a line that starts off down here at minus 5, put an X there, and it has a slope of 2. Now, you know that slope is rise over run. So your rise over run is 2. So what that means is if I run 1 along and I go up 2 and put another X, that gives me a rise over run of 2 over 1, which is 2. And I'll repeat that, run along 1 and rise up 2. Run along 1 and rise up 2. I'll do that another 2 times just to fill up the space. Okay, so now we're going to draw this line here, and then underneath it, underneath the x-axis, we'll make it a dash line, because that dash line is not part of this graph. It is part of this graph, but that's not actually what we were asked to draw. That's just part of our working. We need the mod section. So we need to take any points below the x-axis and reflect them up. So this point here, which is at 2 minus 1, is going to go up to 2, 1. This point is going to go up 1, 2, 3, 1, 2, 3. And this point from minus 5 is going to go all the way up to 5. So now this looks like that. And that is my graph. All right. Pause the video. If you need to go back and revise the y equals mx plus c linear graphs, then do, and have a go at this question on the right. Watch out for the negative gradient there, the negative slope. Okay, so that's the first section done. In the next video, we're going to be solving modular equations.